Okay, so now in the second part in the today's course, I want to talk about scaling strategy in MongoDB. So we should think about like why scaling strategy is used quite popular these days. So first of all, like when you think about back then, like in 1990, we didn't deal with a big size of data. The data size was much smaller, and there were not much data to store. So I don't mean that there was no data. It's just compared to now, the size of data we dealt at the time was much smaller. And also there were less frequent requests. Now we have an online service, social media and social network and our smartphone. So much more requests we send to the online service these days. So online service, if you have it, your server has to deal with more frequent and rapid requests. And also back then, we had the simple data type, most were numbers, and sometimes we had some text to information, but most of the times it was just numbers. So having like a server with a reasonable database size should be enough to handle most of the requests. But now, of course, we have a big data. We have a much rapid increase in the data volume. So every day we are accumulating much more data size. Also, we have rapid requests from the user. Also, now we are dealing with a more complex data type. Sometimes we need for some of the unstructured data storage. So because of the big data, we cannot store everything in one server. It's quite a lot of information. Also, there are a lot of requests from the user. So one server to handle all the requests are quite difficult. So we are having a lot of problem right now. So we have to do scaling at a certain point as the data size is getting bigger and as we are getting more requests to handle. And the traditional way and one of the way to scaling is vertical scaling. Basically, it's about scaling up. So we add more power to the PC. So if the processing power is not enough, we add more RAM. We use a faster CPU, and the storage is not enough. We use a bigger disk space. So we keep making the server bigger and bigger, and eventually we are trying to make a supercomputer like this. So that's the vertical scaling. There are some problems here. The first one is it's costly. It's a very costly approach. Why? It's because of this. So let's say that you are having this PC, which is able to handle about 40,000 operations. So this is a benchmark that I got from the benchmark website. And this is the CPU information here, different CPU here. And this is the benchmark score. And here is the price, average price of the product. And let's say that, let's assume that there is a kind of a capacity that perform operation. Then we can look at one here, AMD Ryzen CPU. And this CPU is able to handle about 40,000 operation. Let's just assume that for easiness, simplicity. And this costs about US dollar 1,450. And let's say that this server is not enough. We want to increase the performance by twice. Then we have to increase this score into twice. Then we can look at this range. So we want to increase this performance into twice around 80,000. Then we can look at something like this 80,000, which is from same company, AMD Ryzen. And the price, the performance increased by twice. However, when you look at the price, it's not twice. So you can say that here it's 1,450, but here it's about 5,150. So it's more than 3 times. It's almost 4 times like this. So you can see that to increase the performance by twice, the price you have to pay for is actually much more. So that's something, that's why it's a costly approach. Another problem is that if you put all in one server, so this server is handling all the requests and storing all the data. What if this server fails? What if there is a problem in this server? Then that's a huge disaster for the online service. So you have to think about that possibility too. So another approach we are talking a lot in the big data system is horizontal scaling. Basically, we are scaling out instead of scaling up. So Basically, we are trying to add more small machines into the network, into the cluster. So instead of using one server, we add one more, so utilize two servers. When it's not enough, we add one more server, so utilize three servers. So we are making a distributed system and network by adding more machines into a cluster. So that's the scaling out approach. In this case, if we want to provide twice faster performance, then we can just pay twice more because we will just add one more server. So the cost increases linearly as the performance increases. So many ideas of how to efficiently utilize this kind of a distributed storage and process big data came out during early 2000s. So one of the huge like a success of implementation was Apache Hadoop. So if you are interested in big data area, and if you probably search something related to the big data, it's possible you may heard about Apache Hadoop. So when it first came out, a lot of people were talking about this. Right now, maybe people are not talking as much as back then because now we have a much more and much user-friendly and easier technology. So we don't talk as much as back then, but still it's a very popular concept. So Apache Hadoop is basically, so I want to briefly talk about this a little bit so that you also have an idea about this. And like in the practice and in the industry, when people talk about this, you should be able to understand. So I'll talk briefly about this. So Apache Hadoop is basically an open source software framework. So it doesn't just mean one thing. It's an entire ecosystem, and there could be multiple software components. And in this software framework, in this Apache Hadoop, the most important thing are these two: distributed storage and processing of big data using MapReduce programming model. So it came out here. So actually, MapReduce programming model was first suggested by the person who are working in Google, from the Google, and then they implemented this MapReduce model into implementation, and that's a kind of Apache Hadoop. So it's a really popular ecosystem. So basically in this Hadoop, the two things that I mentioned were quite important. It consists of storage and processing, and there are more things, but the other things are added later. At first, these two were the most important core components of Apache Hadoop. First one is a Hadoop distributed file system. Basically, it's a concept that what we covered in our class when we talked about introduction to the big data. So it's basically this. It's the concept that we have a big data. We cannot store this into one server because of the size, and we want to manage it more efficiently. So we'll divide this into multiple parts and save it into different server. So that's the concept of this Hadoop distributed file system. And for the processing, and in MongoDB, basically this can be done by sharding and replication. So in MongoDB, so one of the nice thing about MongoDB is that this MongoDB NoSQL database was born to support sharding and replication very easily to the people who are utilizing this system. So this distributed file system in MongoDB is done by sharding and replication, which I'm going to talk about this more details later. And the second part is the MapReduce programming model, which I briefly explained earlier. So basically, this model, MapReduce programming model, was implemented in Hadoop. And then what they do is this: when they have multiple server, it's basically user request to process this big data, then the job will be sent to multiple server. And in each server, they will process data, and the results will be gathered together and sent it back to the user eventually. So there's a map function and reduce function, which will take care of this job. So that was the main concept of the MapReduce programming model. So because I briefly explained this earlier, so I skip this more details here. In MongoDB, again, we have an aggregation function that do this job. So one student asked the difference between MapReduce and aggregation, and actually they are the same thing. It's just a different wrapper. So MapReduce, you have to use your map function, reduce function, and aggregation in MongoDB, it already includes those things. So you can use operators. So how about MySQL? So MySQL is still used quite a lot in the industry. And actually, MySQL is the #1 database system in the world. So still many people are relying on MySQL. But earlier, when we said that if we have a big data, MySQL, like a relational database, will have some problem because it cannot handle all the operation well. And that's true. So when we have a relational database system like MySQL, they are also talking about partitioning of a table. So something like this, you have a really big data stored in a table. So this table size is really huge. So you are not able to store this table in one server. And what you can do is that you have to split this table into multiple tables. So this part, you split, save it into one server. This part, you split, save it into different server. The last part, you split and save it into another server. So that's the concept of partitioning of a table. So at this stage, like a relational database, like MySQL, they are adding more and more feature to handle big data. So in the traditional relational database, what we covered in this course earlier in the first half of the part, in traditional relational database concept, this is not possible, but these days, MySQL provides an option. And many of the traditional, like relational database, they don't want to be traditional forever. So they add more features and they provide more functionality, which is able to mimic what NoSQL is doing. So MySQL, you can partition the table and store it in different servers. That is possible. However, when you do that, it comes with a lot of restrictions and limitations. So something like this. This is a very critical restriction. Use of foreign key is not allowed when you partition your table. So that's one of the really critical restriction, because if you cannot use a foreign key, you are not able to use a join in the SQL. So you have to use MySQL like NoSQL. You cannot use MySQL like relational database. So that's one of the restrictions. So if you use traditional database system like relational database for big data purpose like a NoSQL system, basically you will lose relational database feature. Those will be sacrificed to provide NoSQL like a feature. So that's something you have to consider. So I'm not going to go too much details about this, but if you go here, there are a lot of information about what is the restrictions and limitations when you use MySQL to act like NoSQL. Then some people may ask this question. So if we just use MySQL for handling big data, then does it mean that we are losing relational database feature and it becomes more like a NoSQL? Then can we say that MySQL can be used as a NoSQL also? And the answer is it could be the yes. So in the beginning, actually, in the earlier times, a few years ago, MySQL was a separate product. So MySQL was there as a relational database system. And the company who managed MySQL is Oracle Corporation. So Oracle Corporation made this product, MySQL Cluster. So it has the same name, but this and MySQL is completely different product. MySQL is a relational database, while MySQL Cluster is NoSQL. So they made a completely different product, but they used the same name, MySQL. And this MySQL Cluster was originally developed as a separate product to support the NoSQL features by the Oracle. But later, now, from MySQL 8.0, they actually combined these two together. So when you use MySQL, you can change the setting, so you can use MySQL as a NoSQL. That is also possible. So I don't know, I think this is a little bit complex because by definition, MySQL is a relational database. But if you change some setting, you can use it as a NoSQL. You can sacrifice relational database feature. So I'm not going to go too much details about this because it's less relevant, but you can check more information here in these links. And many of these kind of companies who are adding NoSQL feature into relational database, they are saying that these are new SQL. So it's another term. I just want to briefly talk about this because some people are talking about this term. So NewSQL is basically a class of a relational database management system that seeks to provide scalability of a NoSQL system for online transaction, workload, and maintaining those guarantees of the traditional database system. So back then, MySQL used the MyISAM engine. At that time, MySQL was a traditional relational database. But now, MySQL with the new engine, InnoDB engine, they are saying that, and they are marketing this as the classification of a new SQL. Basically, it's a relational database, but if you want, it can provide NoSQL feature. So traditionally, when we compare relational database versus NoSQL, we used this figure a lot because MySQL was most popular one in relational database. But in this sense, this is actually not really correct because MySQL can be also used as NoSQL in a certain very specific setting. So I briefly want to mention that. So why do we need to know NoSQL then? Because every tool has a different feature and different usage. So even though MySQL can be used to provide to handle big data, different tools have a different strengths and different advantage. So that's why. So still for horizontal scaling with unstructured data, NoSQL is still considered much more easier to implement and much more cost effective. So that's why MongoDB is still most widely used NoSQL data storage in the industry right now. So that's what I want to briefly mention. So here are some of the comparison between these kind of topics. So it will be kind of a good summarize. So I made this table, and it will be kind of a good summarize the information to understand the difference between what people are referring to when they talk about different things. So when they talk about Apache Hadoop, they are talking about software ecosystem. So Apache Hadoop itself is not database, it's more of an ecosystem. And MongoDB is part of NoSQL, so we talk about NoSQL database. MySQL, relational database. So usually when people talk about MySQL, they talk about relational database. Hadoop, to store data and manage data, it can store any data file because it's the ecosystem. You just store data into a storage. In the MongoDB, we are using JSON document structure to store data. MySQL, we are using table structure to store data. Apache Hadoop is written mostly in Java. So some people say that it could be a little bit slower for real-time interaction. And MongoDB mostly written in C++, same for MySQL, mostly written in C++. So they are more faster in theory. And also Apache Hadoop for real-time interaction, usually it's not as good as others because Apache Hadoop is more of a software ecosystem. So there are many different components you have to connect. So there should be some latency between them. MongoDB and MySQL, usually it's better for real-time interaction because they are made for database system, which is able to handle real-time interaction. So Apache Hadoop is usually used for many of the large scale processing, like a scientific analysis or something like that. And then MongoDB is usually used for real-time processing of big data. MySQL is usually used for real-time transaction for the database. So Apache Hadoop, you can integrate it with many other things because it's a software ecosystem. There is a huge analytics library, something like a Spark. And also there are many software components you can add it into the system. And even like MySQL and MongoDB, you can add and integrate with Apache Hadoop. That is also possible. And the MongoDB and the MySQL itself, by itself, it is a database software. So integration is of course limited. So Apache Hadoop, it's more expensive. That's why these days people are talking less about this because Apache Hadoop is a software ecosystem. So there are many different components. So if you want to construct the entire system, you have to purchase many different components. That's why costs can increase much higher. And MongoDB, MySQL, those are much cheaper because it's just one single database storage. And there are many different use cases here. So different companies are utilizing different systems depending on their purpose and the scenario. And also, it's not like one company is sticking with only one system. So one company may use Apache Hadoop, but also at the same time using MongoDB and MySQL all together. That is possible. So here are just some of the examples of the companies that I found online, and they are claiming that they are using this system. So I put it here for your reference, but these are just some of the information here. So that's it. So that's the main difference here. So let's go back to our MongoDB case into the big data management. So again, so the main concept is this. In the MongoDB, in the big data system like Hadoop, we are trying to manage big data. So there's big data which cannot be stored in only one server. So we divide it and we store across multiple servers. So that's the main concept of using MongoDB, Hadoop, and those big data processing tools. So the question is this. MongoDB is designed to do this very well and automatically without you worrying too much. Then what we have to decide is this. So when we divide the data into smaller parts and save it in different servers, we have to think about what will be saved here in A. So what will belong to A, what will belong to B, what will belong to C. We have to think about this. What goes into A, what goes into B, something like this. So defining that will be something called sharding in MongoDB. Basically, sharding in MongoDB is this. In one collection, you have a huge amount of documents. So you have a 1 terabyte of documents, and it's too big to save in one server. So you want to manage it more efficiently. So you may shard. So you have 4 other servers, and you split these documents into 4 other servers. So one server has a part of it, another server has a part of it, like this. And combining all these together across multiple servers, then it becomes one collection. So this is sharding in MongoDB. And when you utilize sharding in MongoDB, you have to define shard key. So shard key will eventually determine where the documents to be stored together. So which documents to be stored here, which documents to be stored here, it will be determined based on the shard key you determine. So shard key is basically one field from the document. You can use a certain field in a document to be used as a shard key. So basically data will be partitioned into shards based on the same value of the shard key. You can think this as something like a grouping. So you are defining what will be the group ID. So in this case, we call that as a shard key. So when do we need to use sharding in MongoDB? The first one is quite simple when we don't have enough disk space to store all data. So when we have a big data, we shard. Also, when we want to increase query throughput, we want to be able to process more operations per second, then we can shard. We can use multiple servers. Also, when you want to respond to queries much faster, so number of user requests, we want to handle more requests from the user, we can also shard. We can utilize multiple servers. Then in case of big data, in case of a performance region, we can decide to shard. So again here, when we have a big data, which cannot fit into one server, we can shard. Also, one server cannot efficiently handle all the operation. We want to utilize multiple servers together, then we can also decide to shard. So there are 2 reasons why we want to shard in MongoDB. So here's one use case. So MongoDB is utilized by many different companies, and this is one company called Foursquare who used MongoDB as their data storage. So I'm not sure whether you heard about this company called Foursquare, but it was quite a popular company back then because of their online service. So what they provided was something like this. You go to a cafe or you go to a restaurant, then you can log into this Foursquare mobile app and you can click the check-in icon. Then it recognizes your location and it says it knows that you are inside a certain cafe. And if you click check-in icon, then you can share your check-in information with your friends. So your friends will know that you just check in into this place, and then the friends next to you will see their information, and they can say that, oh, let's hang out together. Oh, I'm just next to you, or something like this. So it's a kind of a social network to share your activity and where you are and your locations. So Foursquare had 50 million users at the time, and they had 6 billion check-in information. So it's a huge information, a lot. They also have 55 million points of interest and venue. So something like cafe, bar, or museum, those places. And 1.3 million merchants were using the platform for marketing purpose. So basically, if you check in my cafe, we'll give you a free coffee, something like that. So a lot of people were using this service. So they have to handle about 300,000 operations for every second. And they were using MongoDB, and they had about 5.5 billion in their database server to keep all this check-in information. And MongoDB, the Foursquare utilized MongoDB for sharding. So the main reason Foursquare utilized MongoDB because of its easiness of the sharding feature. So at that time, Foursquare had about 11 MongoDB cluster, and the largest cluster had 15 shards to store check-in information. And to keep check-in information collection, so to keep all the documents inside the check-in collection, they sharded it based on user ID. So what it means is this: check-in information of the same user is physically stored on the same database server. So if Foursquare didn't use user ID as a shard key, the user age check-in information can be stored anywhere. So user age check-in information might be here and also here. Then the problem is that when we try to provide check-in information of user A, we have to scan this shard, this server, and we have to scan this server. And we have to find user A information, we have to provide it. So we have to utilize two servers in this case. But if we shard where, if all the documents are sharded on the user ID, it means that by specifying user ID as a shard key, we are going to group those documents together and store it in the same place. So user age check-in information will be all stored in the same location here. And then in the future, when we send a query to the database server, we can only search here the smaller documents, smaller number of documents, and we can return the result to the user. So instead of scanning 500 gigabyte, we can only scan 256 gigabyte of information. So it will be much faster. So that's how Foursquare used the sharding in the MongoDB, and they are able to provide fast read and write operation. So once you want to ask what is the cluster here? So basically cluster is a set of the server. So it's something like this. So there is a MongoDB server, which is able to handle your query. And there are multiple servers, which contains your data. So these are connected to this. And we call this as one cluster. So let me give you a better example in the next slide. How to determine the number of shards you need? So you can actually decide it. So I think it's better to speak with talk with this screenshot here on the next page. So this is a MongoDB architecture basically. So if you want to, let me talk on here. So I think you'll be able to find the answer from here. So when you set up the sharding, basically when you set up distributed computing system in the MongoDB, this will be the full architecture you have to consider. So first of all, there is application. So application is something like a website, a mobile application, or program that people use to communicate for your online service. So users will use this application to send a request or do some interaction with your service. And when you have an application, and if this application wants to send a request to the database, so to communicate with the database, you need to have a driver. So driver is basically handling all interaction between database and MongoDB server. So for example, you made the application using Python, for example, and then you need Python MongoDB driver, something like that. So you can download this driver in the database provider's website. So MySQL driver for Python, you can find it on the MySQL website. MongoDB driver for Python, you can find it on the MongoDB website, something like that. And then the request sent to the application will be handled by driver and send it to your MongoDB server. And we have something called the query router here. So query router in MongoDB, we call this also as a MongoS. And this determines where to send the query request from the user. So basically, query router is the main MongoDB server which receive a request from the user, like a query. And then this query router determines where to send your request to a server, because you will have a multiple server containing different part of information. So based on earlier example, user age information is stored in shard 1. User B's information is stored in shard 3. Then when the query is received by query router will look at your query. And if the query requests search user age data, then the query will be sent to shard 1 like this. And in the shard 1, basically so in the earlier example, let's say that we have a user information divided into 3 parts and stored into multiple shards. Then some part of user information will be here, part will be here, part will be here. So it will be sharded across multiple server. And then in each shard, we have a primary server and secondary server. So primary server is where it contains part of a collection that stores the most up-to-date data. So if user A check in into new place, then we have to add that information into user A. Then that will be added here into primary. So primary will handle write, insert operation, basically. So all the write, insert operation will go to primary. And secondary here is a replication set. Basically, it's a copied backup of primary. So we copy this primary information here. So we have the same user A data here. And this secondary server will handle the read operation from the user. So all the write and insert operation will go to the primary, and secondary will handle read operation, so that a lot of people are requesting to see user age information. Their request can be handled by secondary like this. So this is the basic framework. And we call this part, like here, from query router to the primary and secondary as one cluster, basically. So you can think this as a cluster of multiple server, and each shard can have a multiple server too. So in one shard, there's a primary server, secondary server like this. So that's a basic MongoDB architecture. And you asked how to determine the number of shards you need. It's up to you. It depends on how many servers you have available. So you have to determine that. So let's say that you have like a big collection and you want to utilize multiple server. Then into query router, you can determine that you want to add a digit server as a shard 1 here. You want to add a digit server as a shard 2 here, like this. You can determine this and tell to query router by in the setup process, basically. So I'll show you later how this can be actually done in the code. So we can check that later. So this is another example. So I want to give you a brief example of how this MongoDB architecture and how to handle read and write operation. So let's think about something like a Twitter, like a web service. So this is not exactly Twitter, but let's imagine this is just something like a Twitter social network, something like that. So let's say that we have Obama's account stored here on shard 1. So Obama's information is stored here in this primary. And when Obama writes a new tweet, his new tweet request will go through application, through driver, and through query router. And query router will check where is the primary server for Obama's document, which is stored in shard1. So we send his request to the shard1 into primary, and here Obama's new tweet will be added. And later, this secondary will copy information from here. So we'll have the duplicate information of the primary here. And later, this Obama is a really popular person, so many people are trying to read his information. Then user B and user C will send a request to read the tweet from Obama. So their request will be go through application, go through driver, and go through the query router. And query router check that Obama's tweet will be stored in the shard1. So they send their request here. And their request will be handled by the secondary, which does a read operation. So user B's request will go here, secondary here, and the information, Obama's information is found and sent it back to the user B. And this server is already busy by being used by user B. So user C's request will go to the here, another secondary. And we find the Obama's information and send it to user C like this. So that's how the MongoDB architecture handle read and write operation when the information is sharded and when we are using replication of a secondary data set like this. So another thing we can consider is now the geolocation sharding. So these days, this is quite common. So many international companies are providing online service across many different companies. So for example, like Google, Apple, and all those big companies, they are providing online service, not just in the US, but also outside the US. So those are very common these days. And in that case, keeping all the servers in one country, one physical location has a problem. So for example, let's just say that Google or Apple or those companies have all their data server in the US, then the users in Hong Kong, if they try to use their service, they have to send a request to their database server eventually. And those requests will go through the cable. So we are using wireless here, but eventually this wireless signal will be captured by the our internet router, and our signal should be sent through the wire. So it's sent through the wire, and between Hong Kong and the US, there is an under ocean cable. So under the ocean, on the deep down, there is a really huge cable. So that connects from Hong Kong to, that goes from Hong Kong to mainland and goes to the Korea, Japan, and Alaska, and go to the west coast of the US like this. So it's a huge Pacific, a huge like basically internet cable installed under the deep ocean. So what it means is that even though we think that those communication and receiving requests from internet is very fast, actually it has to go through that much travel. So if a lot of people are sending requests to those international company, of course it will be slower. So we may not notice very easily, but there is latency basically. It will be slower. So if we want to provide a faster service to people living in different country, we have to actually physically put a certain server there to handle a lot of requests from people living in that area. So that's unavoidable. And actually many international companies, for example, like Google, they have multiple database servers and data centers across all over the world. Like Google has many data centers in the US, but also they have a data center in South America and Europe, and also in Singapore, and also in Korea, in Asia, like this. So that's another concern here. So sometimes we do sharding based on the geolocation, so that's possible. So let's say that this is some service like Netflix, something like Netflix, and we are trying to provide a streaming service to the user much faster. And we are providing international service. So users are from all over the world. Then we can utilize geolocation sharding. So Hong Kong, like Hong Kong contents are stored here in shard1. Korea contents is stored in shard2, US content is stored in shard 3, and something like German contents are stored in different shards like this. So we can do that. And also, in this case, what's happening is this. So we can also analyze and understand the user's behavior. So let's say that there are Hong Kong users, and when we look at the Hong Kong user, we found that they mostly watch a Hong Kong movie. So this, the shard for Hong Kong, on the primary, we have a Hong Kong content. We can put this physically in the Hong Kong so that we can serve to the Hong Kong people. And we also found that many also watch Korean TV series. So let's find that by analyzing their behavior, then what we can do is this. In the shard 2, we have the Korean content data stored there. And this secondary is a copy of the primary. So we physically put this into Hong Kong. We physically locate this into Hong Kong, which contain copy of Korean content. And so they only watch German film, so we don't need to put secondary of German database into Hong Kong in this case. And for US users, we know that they mostly watch US content. So of course, this part, the primary server of the shard 3 should be physically located in the US. And we also found that they some watch Korean TV series, then another secondary server of the shard 2 can be located in the US like this. So this is one example of geolocation sharding some people are considering. So basically, they make a shard based on country geolocation like this. And then the secondary part, we can put it into different place so that we can provide the service much faster for people living in different area. So that's another concept of geolocation sharding here. So another question is here. Also how to decide the number of secondary servers. It also, there's no specific way. It also has to be determined by the person who are making this architecture. So how many secondary servers should I have? There's no rule, and MongoDB doesn't automatically give you the answer. So when you design this system, you have to add the server manually by yourself. So in case of MongoDB, they say that it's good to have 3 servers for each shard, 1 primary and 2 secondary. That works the best, but if you want to add more secondary, that's also possible. So the secondary, why secondary should copy the full file of primary? It's because of this. You can think as this. So this is a primary that contains original C part of data, and we make a replication. So we talked about this when we talked about the introduction to the big data. So we make a replication here, then the replication in the MongoDB, we call it as a replication or secondary. This is also secondary because it's a copy of part C. And you can consider this as shard C, like this, because all these parts contains the same data. So when you make a secondary like this, the benefit is that you can utilize multiple servers to handle multiple requests concurrently at the same time. So it's much faster. Also, that's a good question. You asked whether it wastes the storage. Yes, of course, it wastes storage. But the thing is this, these days, storage space is very cheap. Storage is very cheap. So you can using very small money to buy really big storage. So what we are doing these days is this. So back then in 1990, storage was very expensive. So relational database was focused on saving storage. So we make tables and we make relationship to save storage. But in the big data system, storage is cheap. The most important thing is how to answer to the user as fast as possible, how to handle user requests as fast as possible. Speed and performance is more important. So to increase speed and performance, we sacrifice storage. That's what we do in the big data system. And another question is, So we can actually store video, pictures, and documents in MongoDB. So usually what we do is this. In the MongoDB, like information is stored in the documented structure. So we have things in the document. And for actual video and actual picture, we usually store it in another like a data storage. So for example, you have a video, then we have the video link field inside the MongoDB document. And that link will be the actual physical location of where video is stored. So you can utilize that kind of structure. So document will keep only necessary data, and the actual like a big file like video will be stored separately in another storage. And in the document inside, we'll just have a link that connect to that location, the location of the video file. So that's the Beijing, the MongoDB architecture when you use sharding and replication here. So there are some questions. Let me check really quickly. Just like confusing with the concept shard means server. Oh, yeah, I talk about them more later. I totally understand that you might be confused about what is a server here, what is a shard, and what is like a cluster, all those things, right? It's because yeah, this is a little bit complex concept, but I'll give you more example later. Yeah. So let's hang on a little bit. So primary collection stores most up-to-date data. Then where do we store the old data? So primary collection store most up-to-date data. So if you want to store old data, like if you want to store the log information, you can store that in another server. So basically, I think you are talking about data warehousing, which is the concept about storing all the historical data. Then you can make another server which is dedicated to store those old data. So in this case, we are talking about providing online service. So that's here. But you also want to store the user log, something like this. And then which will not be changed basically because it's already what happened. And you want to store historical information, like a stock market information, what happened before. Then you can, so this will be one cluster you design to handle user requests. You can make another cluster with a lot of servers here, which will store historical old data. So periodically, like every month or every day, you can copy this information to here to store old data. So you can, in that case, you can keep multiple cluster. So that's my answer. Okay, so basically, this is a replication concept in MongoDB. Okay, so in one shard, basically, it's one shard. We have these multiple servers. So in MongoDB, we call this as a replication in replica set. So we call it replica set. Basically, there is one. We call it replica set because in one shard, when you have a multiple server, the secondary will copy the information of the primary. So it's a replica set. That's why we call it. And when there are multiple servers, one server will be primary server, which stores the latest data, most up-to-date data. And there will be secondary server here and here. And secondary server will copy information from the primary. So whenever there is update in primary, it will copy into secondary. So they will keep having communication regularly. And it's possible in the future, one server may die. So let's say that the primary server suddenly died. It doesn't work anymore. Then we have two secondary servers here. They still have information which is copied from primary. So they will elect one server as primary. So one becomes primary server, and the leftover, the rest of the server becomes secondary, and it will keep having communication, and this will be used as primary to keep the most latest information. So by having this kind of system, it's done automatically by MongoDB. So as a user who are using this system, they don't need to worry about anything. So that's why MongoDB, they are saying that it's strong against automatic failover. So now here is the part I want to talk more about, like technical stuff of how to actually set up sharding and replication in MongoDB. So this is the basic structure. So now let me, I want to clarify some terms because right now you might be a little bit complex about multiple terms we are using in this section. So to set up sharding, basically, to set up this MongoDB architecture like this, you need basically three things. You need the shard, configuration server, query router, which is MongoS. So query router is this here, MongoS. Basically, it's one server. So this can be a separate one server. So this is basically a dedicated server that receives user request and decide where to send this request. So that's the query router. In practice, you can have a multiple query router for one cluster. So this entire system is a cluster. And in one cluster, you can have a multiple router. So if you have two router, so you can have a two server basically, each server for each router. So some of the user requests will be sent here, some of the user requests will be sent here like this. And then you need to have a configuration server here. So configuration server stores metadata and configuration setting for full cluster of the shard. So basically, it's the place where the information of which data is stored in this shard and this shard like this. So configuration servers, it says it's a replica set here. It means that configuration server can be one server, or you can also utilize multiple server. So if you have a multiple server, and if you use them together as a configuration server, one will be primary and the other will be secondary. It means that the primary server will contain the main configuration setting and secondary server will copy this configuration setting. Okay, so that's the configuration server. And now the next one is the shard. So in this case, let's just think about the case that we have two shards. And each shard is a replica set. It means that in each shard, there could be multiple server. So again, one will be primary. Here, one will be primary. The other two will be secondary. So basically, we call this set of primary and multiple secondary as one shard, one replica set, which will be used as a shard. So that's basically how, this is structured. So to set up sharding in MongoDB, you need to have really many servers, because that's the full purpose of the big data system, and that's the full purpose of utilizing the horizontal scaling out. So in this example, we have two servers for the query router. We have three servers for the configuration server's replication set, and we need three servers for shard 1's replication set, three servers for shard 2's replication set. So exactly how many servers you want to have inside each replication set, you can decide. You may have a 10 server, 16 server like this. Okay, so that's the basic thing. And here, I want to actually show you a demo of how we can actually set up sharding in MongoDB. So this part is very technical, so it will not be in the final test because there are a lot of technical stuff that I'm showing, and it could be also very confusing. So it is okay not to fully understand this part, but I just want to show you this because some of you might be interested in how this kind of things can be set up in the system. So I show you demo on my PC, and it will give you some kind of information about how you can do. So what I'm going to do is this. I'm going to make this MongoDB cluster. So I have one query router, so one server, that is communicating on port number 27018. So that's my Pori router. And I will have only one configuration server. So I will not have a secondary of a configuration server. So this will be on port 27019. And for shard 1 and shard 2, I have two servers each. One which will be primary, another which will be secondary. Also shard 2, I have one primary, another secondary. So shard 1's primary will be 27020 port number. Shard 1's secondary will be 27021 port number. Shard 2's primary and secondary similarly using these different port numbers. Okay, so in this case, basically, if I want to set up this system, this cluster, I need 1, 2, 3, 4, 5, 6 servers in total. So I'm going to use a different port number here to mimic that I have 6 different servers. So let me show you how we can configure this in MongoDB. So first of all, I start with setting up the configuration server. So I start with this one first. So for configuration server, it's just still server. So I needed some place to store configuration setting. So I make a data folder. Under data folder, I make a configuration DB directory. So inside this directory, I use this storage as a place to save a configuration server's setting information. So let me show you this, how I can do. So first of all, I open a new command prompt here. And what I'm going to do is this. So I follow what's written on the slide. So first of all, I make a new directory, data, under C drive. And then I make a new directory under data called config DB, configuration database folder. And then that's not possible. So one student asked whether we can remove configuration server, and that is actually not possible because configuration server is the server that keeps the information about sharding. So where data is sharded, and so configuration server has all these metadata information. So how many shards we have, and which shard has which information, something like that. So configuration server is necessary if you want to utilize multiple server and sharding and replication, then configuration server is necessary. So here, okay, so I go to the MongoDB folder first. So here, what I'm going to use, then I'm going to use this instance called mongod.exe. So mongod, so there are 3 different files. But first of all, the mongod.exe is actual server. So if I use mongod.exe, the actual server instance will be performed here. And I turn on server by using as a configuration server. So I put this setting here. And the name of replication set will be configuration replication set. And the file storage space will be data configuration DB. And IP address, I use my local PC, so localhost IP address. And the port number I'm going to use is 27019. So if I perform this, then basically here, this is the configuration server. So it's here. So I put it here. So it's mongod.exe, configuration server, replication set, configuration replication set, database path, and the IP port number like this. And then I didn't finish setting up the configuration server yet. So I run on the, I opened the configuration server, but I still need to set up that server. So what I can do is that now I have to connect to the server. Let me move to the MongoDB folder first. So here, what I'm going to do is that I'm going to use mongo.exe. So mongo.exe is like a Mongo shell. So I can use mongo.exe to connect to the server. So use this to connect local host 27019. Basically, this one. I'm connecting to this server. So connect to that. And here, I'm connected. So I can perform some query here. What I'm going to do is that I'm going to initiate this server. So use rs.initiate. So rs is a replication set. So I'm initiating this replication set using the following option. So ID is configuration replication set, which we named earlier when we open the server. And this configuration set will be configuration server. So I put true. And who will be in this configuration set? So here is where you determine how many servers you want to add into this replication set. So in my case, I add only one. So I use only one server for configuration server. So I add only one, 27019 localhost, like this. And that's it. So members, there's only one server to be added into this configuration set. And then close this, like this. And then enter. And what you have to check here is whether this OK is 1. So OK is 1, it means it's set up correctly. So currently here, and if I type rs.status, so it shows here, currently it's set as primary because there is only one server here. So if I look at the status, it shows all the information and you can check it here. So basically, it's configuration replication set and configuration server as true. And then members, there's only one member, localhost 27019, like this. And then as you can see, it's a primary server because there's only one server in this replication set. So that's it. I'm done setting. So let me exit. And then this part is done basically. So I finished it, setting up configuration server now. So let me go to the next. So now what I want to do is that I want to set up shard 1. So this is what I'm going to do in the shard 1. So shard 1 is also replication set. There are two servers. One will be 27020. Another will be 27021. So I'm going to set up these two servers with a different port number, and they will save data into different folder. To set up this, what I want to do is that first I want to make a folder for the data storage. So rs1-1 will be used for primary of shard 1, and rs1-2 will be used for data storage for secondary of shard 1. So I make these two folders, and then I have to open the server. So I use MongoDB.exe, and I open the server as a shard server. And replication set name is the shard replication set 1. So shard 1. Database path, where is my storage, is rs1-1. And IP address of this server will be localhost. Port number will be 27020, like this. So type enter, and now it's done. So this one is now my shard server in shard 1 using this data storage. So what I'm going to do is that, so I just finished it making this server. So now I need to make this secondary server. So secondary server, I can follow the same way. So here, I can move to the MongoDB folder. And then use MongoDB.exe to open the server as a shard server. Replication set name should be same, shard replication set 1, because it's for shard 1. And then database path. For this one, I use rs1-2, and the IP address will be localhost. Port number will be 27021, like this. So here, so that's it. That's a secondary server that we are going to use in the shard 1. So we basically made 2 servers here, this one, and the next step is this. So now we have these 2 servers running, and we have to set up these 2 together as shard 1. So that's the next step. So here, what we can do is this. First of all, we can just connect to one of the shard server. So what I think as a primary, this one, I connect to this server, and then I set up that all these are belonging to shard 1. So that's what I'm going to do. So here, open one more command prompt. And then let me go to the MongoDB folder first. Okay, so here, what I'm going to do is that I first use mongo.exe this time to connect to one of the server. So server that I want to connect is localhost 27020. Connect. And here, I will set up this replication set. So rs.initiate. The name of this replication set is shard replication set 1 to represent shard 1. And members here, there are 2 members. The first server to be included here is localhost 27020. And the second server to be included here will be localhost 27021. So those 2 we include as a member in this replication set in shard 1, like this. So do it, and OK says 1, so it's good. And if I type rs.status, it shows more information, like this. So basically, in this replication set, it's a shard replication set 1, that's the name. And here there are 2 members. Member 1 is localhost 27020. Also, actually, that is set as a secondary. And this one, localhost 27021, I think this one is set as a primary right now. Okay, because the name is different. Okay. So it says, oh, but it keeps changing. It's a primary now. Okay. So, okay, so that's it. So let me exit here. So I just finished this. By this, I set up shard 1. The next one, I have to now set up shard 2 using the same way I did in the shard 1. So basically, this part it will be the same. So I just make 2 directory for shard 2, data rs2-1, and C drive data rs2-2. So we make 2 directory, and then use MongoDB, make a shard server replication set, shard replication set 2 is the name for the shard 2. Database path is data rs2-1, rs2-1, and IP address is localhost, and the port number is 27022. Okay, so this is the first server which will be in the shard 2. And let me open one more server to be in shard 2. So here, so use the same thing, MongoDB, MongoDB exe, shard server, and the replication set name is shard replication set 2, and database path is data folder. -2. Oh, I think I made some typo. Let me data. Yeah, let me make sure that whether I made all the folder correctly. Also, I made a typo. I didn't make the rs2-2 here. So let me see. Okay. So let me move back to the MongoDB folder. So here I can type the same thing, MongoDB exe shard server replication set shard replication set2 for the shard2 database path should be C drive data rs2-2 and the IP address should be localhost. Port number should be 27023. So here, that's the second server of the shard2. Put it here. And again, we have to connect to one of the shard. So go to the next stage here. So we can do the same thing here. So we use mongo.exe to connect one of the server in the shard2, 27022 in this case. And here we set up this replication set with the initiate function. What we do is this, for the ID field, we use shard replication set 2. So the time is a little bit over, but let me finish this really quick. Members. We can have 2 member. Host 27022. So we add 2 server like this. Okay, so OK is 1. So if I type rs.status, it should be fine. So let me exit here. So basically, we finished the setting up 2 shards, as you see in the screen. And the next one is this. So here in the next one, what I'm doing is that now I finished the setting up this shard. I finished the setting up this shard. I finished the setting up configuration server. Now the last part is setting up the Mongo router, so query router, which is Mongo S. So Mongo S, I can use this option. So I can use Mongo S.exe and configuration database. I specify what is configuration database server, which is this one. So I specify that, and then I use IP address and the port number. So this one can be simple. So here, basically, I use Mongo S in this case. And then I specify what is a configuration database server, which is a name of a configuration replication set, which is running on localhost 27019. So IP address of a query router will be localhost, and the port number will be 27018, like this. And then now it's running here. So that's our query router. So basically, whenever in the future, whenever we send the query, we have to send the query to here, localhost 27018. Then this will be handled by the query router. And next stage, this is the last one. Now we have to add a shard. So when we set up earlier, we add in this query router, we added this already on the setting. And now we have to add a shard1 to here, shard2 to here by using this option. So we have to connect to the MongoDB query router first. So here, can go to the MongoDB folder again. And we use the mongo.exe to connect to localhost 27018. So we connect it to MongoS. It shows MongoS here. And here we are going to add some shard. So the first shard we are going to add is a shard replication set 1. It has a 2 server, localhost 27020 and localhost 27021, like this. Okay, so we add it. Okay is 1, so it's added correctly. And now we add a second shard. So shard replication set 2 with the server on port number 22 and 23, like this. And then it's also okay 1. So it's added correctly. So that's it. So we added everything into the query router. And the next what we can do is this. Now we can actually go to the connect to this MongoDB query router on the robust3t, and we can try something to see whether sharding is done correctly or not. So I can open robust3t here. We actually already have it here. And close this, and we open here. So currently we are using our local DB, but we have to connect to query router. So let me open this screen and let me create new connection saying sharding test and localhost, and the port number was 27018. So save this and connect. And now I connected to my query router here. So what I'm gonna do is that I right click on it and let me click open share. And here, let me first make a test DB database. So right click here, create a new database, and let me make a test DB so that I can test something here. And let me right click and open share here. And we have to first enable whether the database will allow sharding. So I use the enable sharding option and type test DB here like this. And then perform this query and check it. And here, OK field is 1. So it's done correctly. And let me right click on the test DB and open share. So this test DB, we enable the sharding. And what I'm going to do is that I will populate some data. So use the gyps nyil.js file and perform this. And let me open one more share. And let me open the second file, which we used in our class. And let me perform this again. So we added a lot of information here. So now in the test DB, in the collection, we have CD collection containing the data. And then I'm going to perform this step here to test sharding. So what I'm going to do is that I want to shard based on the state field. So I can make index first in my case. So I'm going to use index to shard so that the sharding can be done more easily. And then I add, so basically I make an index based on the state field, and I use this option called the ensure index. And if I use ensure index, I can change the structure of index. So I use hashed index. So basically, instead of like a real state value, like text value, I use the hashed index so that it changed into numerical value and index is created. So I perform this. So it's performed correctly. OK is 1 here, and also OK is 1 here. And then open new share. And here now I'm going to add collection to be sharded. So test db.cd. So basically CD collection inside the test DB database. And here I determine the shard key. The shard key I use the index which we just created. So basically inside the CD collection, I have a multiple index. I created this state hashed index, and I use this hashed index here as a shard key for CD collection. So in the MongoDB, sharding is done at the collection level. So you have to enable database to be sharded first, and you have to tell that a certain collection should be sharded based on a certain shard key. So if I perform this, it's performed. OK is 1. So that's it. So later, I can check this. So for example, here, I'm not sure whether it's sharded correctly. So if I want to go check, I can go here. Here, I'm connected to the Mongo S. So here I can type sh.status. Then it shows the sharding status that we have here. So basically, it says that there are 2 shards here. So one here, another here, which we set. And there's a configuration server database. So it has some information about the shard. And then currently we have a testdb.cd, the CD collection. And the shard key is used as a state field. But it looks like in my database, it's only saved in the shard 1. So here, state field for this key, the state field from min value to the max value all saved in one shard. It's because there could be multiple reasons. One of the reasons is because I don't have a lot of huge data set. Then they just store in one server because that can be more efficient. So that's what you can do. So here, let me quickly finish this. So basically, yeah, that's how you can set up sharding based on the MongoDB architecture. And if you, so in this screen, it has more information. So if the collection is split into multiple chunks, then you will be able to see this things basically. So in this case, in this screenshot, the collection is split into multiple chunks, and it can be saved into different shards. So that's what you can see. So basically what I want to mention is this. So this part was very technical. So what I showed here, the technical part of the sharding, how to actually set up sharding, you don't need to worry about this. It will not be on the final test, but I put the information here so that you can use it as a reference. So in the future, you want to test it by yourself, or in the future, you need to shard data into multiple servers in your a small project or in your company or in your organization, then you can use this as a reference and you can start from there. So I put this information here, and I also showed the demo here today because it could be useful for some of you who are really interested into this area. So I hope that this information can be useful. And the last slide here, I put some information about how to set up a user account in the MongoDB. So basically, if you want to make an admin user, there's an admin directory server, and here you can add a user and something like this. It's very straightforward, so I'll skip this explaining this part because all the information is on the slide and you can just do it by a few clicks.